Data science is very exploratory work, is very iterative work. So you will end up writing very dirty code, and that's okay. And that's the world that we live in, right? Even after like 10 odd years of experience in this particular industry, if you actually pick up any of my notebooks, it's going to be very dirty work. Neurologists, computer scientists have heavily been inspired from, and they've gone about building this concept called as artificial neural networks, which have now transpired into your modern day, generative AI algorithms in some form.
I would like to know more about what goes on in a data science role. Basically, let's say if somebody who's working in organizations such as yourself, what is the day-to-day task they come across?
There are 3 to 4 types of organizations that you have out there, or 3 types of data science roles that exist out there.
Hello everyone, welcome to the first episode of Intellipaat Podcast. With this new segment, we will be bringing in a lot of tech experts and people working in today's thriving IT domain. We will talk about a vast array of technologies such as data science, cloud computing, artificial intelligence, UI UX development, and much more around the IT industry spectrum. For today's episode, we are honored to have a distinguished guest with us who brings over 10 plus years of valuable experience in the field of data science. He has worked with Microsoft in the past and currently is leading a team of data scientists in one of the fastest growing companies, AB InBev. We have Mr. Srinath Sivalenka with us. Today, we will be discussing various facets of artificial intelligence that are emerging in the market. I also believe that this podcast is going to help you understand various trends that are emerging at the forefront of AI. So I would like to request all of you guys to stay tuned until the end of the podcast.
So we have Mr. Srinath with us, who's working in AB InBev as a data scientist, and he has proved his mettle in the data science industry for the last decade. So it's an honor to have you, sir. So would you tell us how your journey has been in data science so far?
Hey, firstly, thank you so much for having me in here. My journey started I guess around 10 years ago. So I was a mechanical engineer. Like every other engineer, you finish your engineering and try to figure the rest. That's the same with me as well. Interestingly enough, right after I finished my engineering, I was evaluating like what are the options that I have out there. One of the interesting opportunity that was available out there was this field called analytics. It was, people were starting to call it data science. It had many names back then: statistics, analytics, data science, and whatnot. So one of my friends came up to me and he said, "Hey, you know what? There's this new field. Why don't you give it a shot?" My love for math kind of automatically drew me into this. Spent some time, evaluating if this particular field, if this particular industry is going to help me, or if I'm going to get interested in this. And interestingly, I did a course. I did my master's in artificial intelligence. Transitioned into this field completely from a mechanical engineer who knows gears and wheels all the way until software. It was a journey in itself. Like I of course had my challenges. Then joined a couple of startups, it was a hard grind for me the first few years. These startups primarily were focused on building entry level data science applications, data science solutions. Then moved on, worked with the telecom giant Verizon. I worked there for a few years. Again, that company had its own challenges because data was a massive issue. The BFSI industry and telecom industries have their own challenges in terms of access to data, so that was another issue. Then moved on, joined Microsoft. I spent close to around 4.5 years there, and then here I am at ABI, the world's largest brewing company. It's fun. So currently I lead a team of around 15 data scientists. My responsibilities here entail building generative AI applications, recommender systems, and stuff like that.
All right. So it's rather interesting, how you started your journey with mechanical engineering. So I would like to know, and obviously everybody else would also like to know, what were the challenges in the beginning? Because when you started out, the data science domain, as we know today, was not very elaborative. People did not know where to start, what to study. So what were the initial challenges that you must have faced?
Yeah, it was interesting because when we started, the data science industry itself was still in a very, very nascent stage, right? People are still figuring what was data science and everything. So the challenges that I had, firstly, there were two kinds of challenges. One, firstly, to tell myself that this industry is something that I can actually place my bets on. Like, I was a engineer, like trying to figure what's like the best thing, and like most of us, we have that risk-taking appetite at that point in time. So I kind of piggybacked on that. And thankfully enough, that worked out for me. I must be very, very honest here. It was an absolute, I just winged it. I had no clue if this is going to work out for me or not. And it just worked. But on the hindsight, when I think about it right now, I think the challenges that I had, one was I had no programming experience. Right? As a mechanical engineer, the only programming that I learned was CNC programming. I almost flunked my C programming paper in my first year of engineering. So it was an absolute bummer for me. Right? Programming was just not something that was my thing. So that was like a huge, my obstacle for me to surpass. But what I realized is once I entered the field of data science, once I was learning data science and AI, the way you do programming with data science and AI is actually very different from how a software engineer approaches this. So that was very, very pleasing for me. It was pretty much like how you would use a calculator. Back then, we weren't even we weren't building it on Python. We were doing it on R, which was a much more simpler programming language. So that helped. Honestly, that helped me bridge that gap. And the other issue is, because this was a new field for me, I did not understand the corporate structures. This was more on like my personal challenges. I did not understand the corporate world as much. So that was like another aspect to it altogether. But those were like the couple of interesting issues. Programming was one of my bigger challenges at that particular point in time. And then, of course, once I entered my first job, I understood how this works, how the dynamics work. Then it became very, very easy. It's just a matter of those 3-4 months in your first job.
All right. So since you mentioned that programming was rather challenging for you because you were coming from a mechanical background.
Okay.
So I think it's similar for a lot of people who are trying to transition to data science. So what would you suggest? Like what kind of area they should primarily focus on, and then they can build from there.
See, in the field of data science, right? I mean, and this is exactly what I want people to understand, right? So when you talk about programming for a data scientist and programming for a software engineer, these are completely different beasts. The fundamentals may be the same, but the way you approach it is very, very different. So when you are a programmer, you are working in a very deterministic environment, meaning you know what is the input, you know what the output is, and you're expected to kind of code. See, for example, I need a website. I know that I need I need the header here, I need the body here, I need the footer here, the sitemap needs to sit here. It's very deterministic. You know exactly what you want. There's a functional spec. Programming becomes very easy. But with data science, that's not the case. Data science is very exploratory work, is very iterative work. So you will end up writing very dirty code, and that's okay. And that's the world that we live in, right? Even after like 10 odd years of experience in this particular industry, if you actually pick up any of my notebooks, it's going to be very dirty work, and that's fine because that's the nature of our work. So it's probably okay for people to write dirty code and not shy away from it. The second thing is, what I realized at that point in time, what benefited me significantly is always pair programming helps. Right? I had a friend of mine who was very good at programming. I used to sit next to him and watch him write code. And I ended up learning so much from that. I think that really accelerated my learning path. So pair programming as a concept is a very, very popular concept. I think people should embrace this as much as possible. Try to write code in pairs, especially when you're learning, rather than doing it with one single mind. That way you will not have roadblocks. That way you're discussing, you're always trying to write code differently, or you learn from how the other person is writing code. The logic, the algorithms become much more simpler. So that helped me, again, to be able to write faster code. I wouldn't say better code because better code only comes by practice, but at least I was able to write code much faster in that sense. So yeah, this is, I guess, like an advice that I would generally give anyone in this particular industry. The last part here is because of the iterative nature of the work in the field of data science. There have emerged two different work streams, or rather two different job profiles. One is of a data scientist and the other is of an ML engineer. Now, this is another confusing aspect to a lot of people, and I think maybe we should talk about this. A data scientist is responsible for, of course, building the algorithms, building models ground up. An ML engineer is responsible for taking all of that, making the code scalable, putting the right kind of engine under the hood, giving it the right kind of compute, making sure it works at scale. So an ML engineer is expected to have far better programming skills, whereas a data scientist is expected to have far better, I would say, algorithmic skills, machine learning skills, so to say. So again, it also depends on what you're aspiring for. More often than not, people kind of get confused between the two and they conflict in job requirements and everything. So yeah, that's, I guess, another dimension to the same question that you asked.
Right. So cut to a lot of pair programming that you did, and all this while you've been great with all the work that you've done with Microsoft also. So now you're working in generative AI. So what I would like to know is there's a lot of confusion in the market. So what exactly is generative AI, and how do you differentiate between something that is not?
Yeah, so a little bit of history, right, around how generative AI has come to existence. So maybe I'll take that liberty to go one step back and then maybe come all the way through to here. Historically speaking, right, the field of data science and artificial intelligence is essentially like the all-encompassing mothership, so to say. And the idea of artificial intelligence is to kind of build intelligent, smart, autonomous systems, smart agents, so to say. So, for example, the YouTube recommendation engine is also an AI system. Your self-driving Tesla car is also an AI system. The end objective is to build something that is intelligent like humans. That's the end objective. That's the goal state that we're all trying to reach. As a part of the artificial intelligence world, there is a subfield of AI called as machine learning, which makes all of this possible. And there's a subfield of machine learning. And by the way, machine learning is a field. What it tries to do is it tries to learn from historical patterns. So there is a washing machine. It washes clothes. You put clothes in it and you press the buttons in a certain fashion. It is trying to automate a few things. But imagine if it is able to figure out the right kind of temperature that it needs to run, put the water in, the right kind of speed that it needs to run, the right kind of mode that it needs to run. Imagine if it's able to do all of that for you, then that becomes a level of intelligence that we probably might be able to consume. The idea is machine learning is a field which takes all of that historical information in and tries to build that intelligence, extracts patterns and builds intelligence. Now there is another layer to this called deep learning. Deep learning is an industry which is like machine learning, which is also trying to solve problems, but which it is trying to solve problems like a human brain. So we are inspired by, let's say, how our human brain works. Human brain is probably one of the least understood, one of the most complicated systems that exists out there. So the human brain is where, I guess, say scientists, neurologists, computer scientists have heavily been inspired from. And they've gone about building this concept called as artificial neural networks, which have now transpired into your modern day, generative AI algorithms in some form. Now, traditionally, the deep learning algorithms that have been built, this field was initially set up to solve certain kind of regular problems. Like, for example, is this person going to watch this video or not? Is this person going to purchase a product or not? Is the person in the image a male or a female or whatever gender? Or is this particular image, let's say for a self-driving car, does this image have an obstacle in it or not? Or it could also be, is this text positive or negative in sentiment? Does this text have enough Does it have a noun, pronoun? These kind of problems. All these problems come under a category called as discriminative AI. Discriminative AI meaning the algorithms, what they are trying to learn is there are two categories or n categories, and they're trying to learn if one category is different from the other. Then there is another category of problems called as generative AI. Discriminative AI and generative AI. Generative AI, what it does is it learns how the data is distributed and creates new content. This new content creation is what we today very popularly embraced as ChatGPT. So based on ChatGPT, what it has done, for example, is it has gone through lots of content in the world, and now it understands the nuances of language. So when you ask it a question, it just does not pick up a sentence from, let's say, all the books. It actually tries to create new content for you. It actually tries to write new sentences for you. And that is what ChatGPT is. That is what generative AI is. So you could create text, you could create images, you could create videos, you can create audio, you can create songs. You can basically have under one person's voice, have him sing like another song. You can do all of that, a lot of fun stuff. But that is generative AI for you. When you're creating new content using AI, that comes under the category of generative AI.
That was quite elaborate. And I came across a term called explainable AI when I was reading about generative AI as well. So I would like to know what exactly is the concern here that is raised when you say explainable AI, because something that is being generated, so you would want it to be accurate to a certain level. So is that something that is going to be related to this explainable AI? Can you please shed some light on this?
Sure. So again, explainable AI is, so generally, right, one of the fears that most people would have with artificial intelligence is, hey, look, here's a machine that's making decisions on my behalf. Hey, look, there's a machine that is going to take away my job. There's certain fears with artificial intelligence. Of the kind of fields that I mentioned, deep learning specifically is more like a black box. It's not very easy for somebody who does not understand the field to really see how the algorithm is getting to a certain output. It pretty much operates like a black box, and that scares the heck out of people. They're like, man, I'm putting something in, it's throwing something out, this seems to be right, but I don't know how it's getting there, so that's scary for me. And we have, as human beings, we have trust issues by default. So now the question is, how can we make this experience a little seamless or less scary for non-data science practitioners?
General population.
For general population. That's where the field of explainable AI comes in. Explainable AI, what it tries to do is it tries to exactly identify. So for example, in a lot of countries, we use algorithms to determine if a particular person would default on their loan or not. A lot of banks do it. So loan default algorithms, credit scores, credit algorithms are very, very popular algorithms that are there out there. Like, you have a credit score, I have a credit score, and these credit scores are driven by algorithms. Now, in a lot of countries, if that credit score, let's say, is determined by, credit score could be determined by gender, or let's say by ethnicity, by race, religion, and if you are denied of, let's say, certain loans or let's say public services on the basis of any of these factors, then that's a massive issue. It's an issue in terms of governance, issue in terms of security and stuff like that. So the point is, if I'm able to exactly narrow down the factors that are causing the algorithm to give a certain output, that makes it a lot simpler. So the explainable AI is a subfield of machine learning, subfield of artificial intelligence, which tries to exactly determine the factors that are contributing to a certain output. So if I say that the person is going to default on a loan, then I should exactly pinpoint and say what are the reasons that this particular person is basically going to default. So it could be, let's say, his previous loan history. It could be, let's say, the fact that a person has very high credit utilization and stuff like that. if in case in this process there are certain factors that come up which are a little controversial, then Explainable AI also gives you the ability to kind of mitigate risks associated to that. So yeah, this is essentially the field. It's more to provide to make data science and deep learning a little more transparent and translucent rather than how the natural opaque nature that it has.
Right. Yeah, I think that was quite insightful. So moving on, I would like to know more about what goes on in a data science role. Basically, let's say if somebody who's working in an organization such as yourself, what is the day-to-day task they come across?
Yeah. So again, I'm going to answer that in like 3 steps. First is, of course, we'll have to think about the different kinds of roles that these different companies kind of have. Different organizations. So, for example, there are 3 to 4 types of organizations that you have out there, or 3 types of data science roles that exist out there. One is, let's say, out and out research companies. Your companies like OpenAI, companies like, let's say, Microsoft Research, companies like let's say Google Research, Google Brain Teams for that matter. These are out and out research people. They're working on some of the most cutting edge stuff that you and I probably cannot even understand as common public when I say it. And it's not to say that we cannot aspire for it. It's just that it's the nature of the work. You need to be built for doing research kind of work. And that would require you to, of course, be academically extremely strong. That's one category of problems, right? The other category of problems that people generally solve, or the other kind of data science roles that you have out there, are in-house, let's say, data science teams. So, for example, a company like mine, Anheuser-Busch InBev, we are a CPG company, consumer packaged goods company, and we have our own data science team. And we are an in-house data science team that is trying to solve problems for our company internally. So the thing that is needed here is a data scientist is expected to, of course, understand the issues that our company faces, understand the CPG industry, and then translate those business problems into actual data science problems and actually solve them. The third kind of companies are product companies, like, for example, Microsoft or some of the others, where, let's say, you're building an application like PowerPoint, or let's say you're building a product like, let's say, Outlook. One of the things that you need to be able to do there is you are building a product, you would want to embed AI into that product. Let's say I have a product like TikTok, or let's say your Instagram or the others. You'd want to embed AI into it. So here you're building products, building data science capabilities that sit in that particular product. Like, for example, recommendation systems, right? When you're watching reels one after the other, coming up with relevant content. So that's another kind of role. And then there's the last category, which is the most prevalent category in India, which is the services industry. Like your Accentures, Infosys, and TCSs of the world. You have a client request, you have a client problem, you're doing essentially tech consulting, you have a problem from the client, and then you're expected to solve it. For, you're going to spend like 2 to 3 months solving that problem, put it in production, or maybe do a POC and then move away from that and try solving something else. In each of these, you of course would need different levels of skill set. The skill set is very different across each of these. For an entry-level data scientist, getting into a team like the services industry is actually much more easier, because the depth of knowledge is not expected to be very high.
Right. Sorry to cut you off. So when you say it's going to be a little easier for them, so on what parameters, like?
Yeah. So again, the parameters there are, when the nature of work in the services industry is typically around doing POCs. You don't have to put. You're not always expected to do production grade work. So you could get away with doing quick, rapid POCs. You could get away with not building the most state-of-the-art code, so to say. You don't have to write state-of-the-art code. So the requirements in terms of programming skills is not going to be as high as, let's say, what it would be for a product company, so to say. So number one there. So the bar in terms of programming requirements is relatively lower there. You're not expected to have extensive domain knowledge because you're often going to be working with multiple clients and multiple businesses, so to say. So you're not expected, as an entry-level data scientist, you're not expected to have knowledge across all of it. So that's not another thing that people are going to evaluate you on. So what is it that they're going to evaluate you on if you're applying for a job in, let's say, an Accenture or let's say an Infosys or any of these? They're going to evaluate you on your core data science skills, right? Your machine learning, basic programming, SQL, these kind of skills is what they're going to evaluate you on. And that is something which you would learn in most courses, right? Even in, and that is where, I guess, if you're able to spend enough time in just picking up those skills, then you are job ready in that sense, at least for those markets. And if you're able to do some projects, that will make you job ready at least for those markets. But when it comes to product companies, it's a little difficult because in product companies, the expectation in terms of programming skills is already going to be very high because you need to be able to put code in production. You need to be able to do you need to be able to write test cases. You need to make sure that your code is well formatted, object oriented programming right from the get go, because you're pushing a change straight into an application that a user is using. So you need to be very, very good with your programming skills. You also need to understand engineering platforms and stuff like that. You need to have much more broader knowledge in terms of cloud architectures and stuff like that, so that you contribute to it and it doesn't become a challenge for you. So that's the second kind of, in product companies, it's a little more difficult for an entry-level data scientist to get there. In the product company, it's a little difficult. Not to say it's not easy, it's impossible. It's just that if somebody has enough programming knowledge, then that becomes easier for them to get into a product company as well. But that becomes a challenge. The third category is in-house data science companies, like captive units, GCCs is what we call them, Global Capability Centers. Now, these companies are a little interesting. Because they expect you to have some knowledge about data science, of course. The programming skills do not have to be extremely high. You can have entry-level data science skills plus one maybe. But what you're expected to have is some domain understanding, some problem-solving capability. So if, for example, if I tell you, hey, you're working for, let's say, Unilever, or let's say you're working for let's say, a telecom company. Let's say you're working for Airtel. How would you increase the customer base? So an interview question is typically going to look like this. But somebody's going to ask you an actual scenario in their company, and you're asked to you're expected to think that through and actually come up with a solution. That's the third kind of jobs where the skill set requirement is a little more on the business side of it. Tech and data science could be pretty similar, but with let's say the others. But the additional expectation is for you to be able to think a little more business. The fourth category is the most difficult to get into. You need to have research backgrounds. You need to be very good with coding, of course, but I think you need to be able to spend time in going into extensive amount of math, the hard grind, the ability to read papers, make sense out of it, and then work on the most cutting edge and the bleeding edge of stuff is what the research work essentially is. So that's the gamut.
It's nice that you mentioned all these, researchers doing a lot of cutting edge technology work. So I recently came across one of the projects that they were using for air pollution. Basically, they want to understand how it works, like per person wise, how much area we are getting exposed to pollution, and they're generating the data so that they can use data science in this. So similar to this, how many, can you tell us more about your project also, like what you are working at your organization?
Yeah, so I think again this is where problems from industry to industry change. The kind of challenges that we have, let's say in our space, in the CPG space, we've got problems. So for example, here you go, right? We are doing company.
Yes.
And these kind of problems I'm referring to are actually very similar to, let's say, a company like a PepsiCo, like a Coca-Cola, any beverage industry. Or any CPG industry would have very similar problems. So our problems stem from, like for example, for a beer brewing company, one of the most important problem that we try to solve is marketing, because that's what you get sold at, right? I mean, The product, of course, is going to be very important. So marketing is going to be, let's say, one of the most important areas where we try and solve problems, right? Allocating our budgets efficiently, right? So if you have a $5 million, well, the number is just a random number for now, but these numbers are much bigger. Let's say you have $5 million as budget for marketing this year. How efficiently can I allocate these $5 million across different media vehicles that I have, right? How much do I spend on social media? How much do I spend on, let's say, traditional media, and so on and so forth? That's an interesting data science problem in itself. Then comes, if you think of it, there are problems that we very frequently solve in terms of operations as well. So we have operations, supply, logistics. So logistics is an interesting case. Like, for example, last mile delivery. So I have truck drivers who carry, let's say, my beer crates, and then they deliver it to stores. Now the question is, how can I optimally map their route in such a way that they can cover all the points that they need to cover in the most efficient possible fashion? It's very popularly known as the traveling salesman problem, if you think of it. So, or traveling salesman or traveling postman problem. So you need to deliver 5 postcards, or you need to deliver 5 things at 5 different people who are at different places. What's like the shortest path that you can map around? It's a very common problem, but that's the problem that we try to solve, of course, with a lot more complexity. In supply and procurement, we solve problems as well. Like, what's the best way that we could procure? So, for example, to make beer cans, you need aluminum sheets. Of all the suppliers that exist out there, what's like the best way for me to procure aluminum sheets at the cheapest price? Or how can I do hedging? Meaning, how can I buy something up front and keep it in such a way that I benefit by purchasing it ahead of time? So for that, you need to do a lot of forecasting. You need to do demand estimation, and based on that, you need to be able to buy stuff up front so that you gain benefits of buying it ahead of time. Same with raw materials. And then comes, let's say, how can you efficiently, on finance side, we've got a lot of problems. So, like, who are my the folks that I supply to? Which of them are likely to pay me back on time, and stuff like that. So the problems range across the board, right? Starting from marketing, supply, logistics, finance, people analytics is an interesting group that we've had in our company to identify which employee attrition, to identify succession, to do succession planning and stuff like that. So the problems that we solve are going to be across the board. And then, of course, in and around it, we would have things around how do I increase sales, doing sales forecasting, stuff like that. So those are like pretty much the gamut of problems. And this is the same across industries, be it across this particular industry, be any CPG company would be solving the same set of problems across the board.
Right. So why I ask you this is because a lot of people have this, a very deep perceived notion that they want to study data science for only domain-specific knowledge. Let's say for only domains like who are building robots, for example, and that you mentioned CPG companies. So, is it safe to say that if you are a problem solver, if you can think of a problem statement, get data, use it to make a model, let's say, for example, get to a solution, does that make a good data scientist? Or is it just that you just have to identify a problem and get the solution?
Yeah, so that is the core skill of a data scientist today, right? The perceived notion that you mentioned is absolutely true. Most people also think these days that if I learn Python, I can become a data scientist. Or if I learn programming, I can become a data scientist. Or let's say if I learn machine learning, I'm going to become a data scientist. That's true, but you're missing the core skill of a data scientist. The core skill of a data scientist is to be able to map a business problem to a data science problem and identify what kind of technique can you actually apply to solve it. The solving part of it is actually getting automated to certain extent, right? Algorithm building is getting automated through AutoML, writing code is getting automated through generative AI. So there are automations in that space. So if people are investing their time in learning a skill, they should rather invest their time in learning the problems or identifying how they could solve the problem, rather what problems to solve, rather than how they would need to solve the problem. That spot on. The skill set is on in being able to translate a business problem into a data science problem and articulating that exactly into like the different steps that you will have to take. Where do you get your data from? What kind of data sources do you need to use? That's where the skill is for a data scientist.
Alright. And one more thing, like what particularly I have seen in a lot of job descriptions that we see nowadays, from what we were seeing 5 years ago, a lot of companies are mentioning MLOps, as a primary skill for even an entry level data scientist. So is that a trend nowadays in organizations? Are they expecting people to normally know MLOps as well, with the general knowledge of all these algorithms and everything?
Yeah, again, it's a bit of a trend, and you use the right word there. It is a bit of a trend. It is a bit of a, I think, catch-all kind of thing. I think job descriptions in the data science industry have gotten better over the years. I think there is still some scope for improvement. But if I were to, again, talk about different roles, right? So you have a data scientist, you have an ML engineer, you have an MLOps engineer.
Yes.
MLOps, ML engineer, people tend to conflate between the two. You have a data engineer, and then you have the front-end developers and the others. So that's the stack generally that you're operating with. A data scientist is somebody who is very good at building models, understands machine learning, understands concepts of machine learning and so on. An ML engineer and an MLOps engineer. An ML engineer is also like a data scientist only, but is responsible for making the code more production ready, packaging the code much more efficiently, making sure that it is scalable, making sure that it is parallelizable, so on and so forth. An ML ops guy is a little different. The responsibility of the ML ops engineer is to be able to build training pipelines, inferencing pipelines. What do we mean by that? Like, for example, if I have a model in production, how do I firstly put it in production? And if there's fresh data coming in, how do I continue to retrain it? Right? The whole retraining cycle, by building all those pipelines and everything, that's what an ML ops engineer is expected to do. Now the thing is, while it would be amazing to find somebody who has all of these skills, the reality is you seldom find people like that. It's not that easy to find, especially at entry level, or even if you take, for example, somebody who's 5-6 years experience in the industry. It's very difficult to find somebody who's worked across all of those. Like with 7-8 odd years of experience when I was working in Microsoft, that's actually when I had the opportunity to work across all of them. It's not that easy for somebody to procure skills across all of them, because these are fundamentally very different skill sets. So in job descriptions, yeah, people do put it, but it is always a good to have. If you're hiring for a data scientist, MLOps skills is a good to have, but it is not mandatory skill at all. Somebody who has that skill set would have an edge over the others, because you pretty much are a generalist. Like you are able to build models and deploy them end to end. You are a hotcake. So either if you want somebody with all those skill set, get ready to pay like a bomb to that individual, or then you need to compromise on one of those skill sets. You need to be very sure exactly what you're looking for in the individual.
So there's something else I want to talk about, which is Edge AI. Since you have worked, very elaborately in this field, please shed the light on that as well.
Yeah. So again, I've worked in the AI space, not so much on Edge, but my understanding of Edge in general is taking AI all the way until the edge systems, so to say. So when you say edge systems, something as simple as, let's say, on the farm, you would want, let's say you have a field, you have an agricultural field. Now the idea is how do I use AI to increase productivity there, right? So, and this productivity could be by simplifying the lives of the farmer. You could use drone imagery to identify if there are pests. You could use, let's say, AI embedded in farm equipment to help you harvest, let's say, the right kind of fruit and figure out if it's at the right time for you to harvest it or not. So you could do all of that, and stuff like that is already happening, right? And a lot of these companies are partnering with, let's say, these farm equipment manufacturing companies. Like the tech companies are partnering with companies like Mahindra's of the world, and they're coming up with these projects very, very interestingly. That's edge in a lot of ways. So you're essentially taking it all the way until the edge systems. It could also mean on factory floors. Factory floors, like how do you use AI to improve manufacturing processes? So, for example, if let's say I have and this is something that I have seen myself. There's a battery manufacturing unit. We've got some fantastic battery manufacturing units here in Pune. Now, a typical lead acid battery would have lead grills, so to say. It's a mesh, so to say. And if that mesh has certain issues, and if there are these perforations are not made correctly because they act as an electrode, they could potentially fail when they're used in real world. Like let's say these are car batteries that I'm referring to. There's no way to test it. The only way to make sure that these work well and there's no way to repair lead acid battery. Right? I don't know if you've ever seen anyone repairing a battery. The only thing that they would do is just pour acid back into it or distill water back into it. That's the only thing that you do with these batteries. So the point is, once it's gone, it's gone. I mean, the only way to figure what's the issue is to actually cut it open. So there's no way to salvage something. So the only way to make sure that they reduce returns is by making sure that they have these processes efficiently done, right? The manufacturing process has to be very, very efficient. So imagine if we were to use artificial intelligence to figure out if that mesh creation, if it is actually being done well or not. Right at the edge, exactly when the mesh is getting created. Imagine I have cameras, I have AI equipment, which is capturing imagery and then figuring out if that mesh is properly being created or not. That is edge AI. It's a lot more effective. Edge AI is the AI that we use is fun, is entertainment. Most of us use AI for entertainment these days, or rather are leveraging AI in some form or the other for entertainment. But this is essentially like the use at the very edge, so to say. So yeah, that's the edge AI space. I haven't personally worked on it. I'd love to at some point, but yeah, that's an area of interest for me as well.
That's quite interesting also. And when you say it's mostly for fun, AI, people what they're coming across, essentially this is what it's going to change the world.
Oh yeah, absolutely, and it is changing the world already. Like, and a lot of companies these days are using AI to drive productivity gains. Like for example, we are today empowering our data scientists, our developers in my company, to use something called as GitHub Copilot, which is something that helps people code faster. And we're empowering them with it, and we're actually seeing productivity gains through these capabilities. We've hosted our own in-house ChatGPT so that people can actually start asking questions internally. We wouldn't want, of course, people to post company-related stuff on.
Yeah.
So we have our own in-house ChatGPT, which helps people answer questions. So it is changing industry across the board. It's just that we as a common user would probably not see all of it. You would still see relevant reels on Instagram, or we would still see if YouTube is recommending me the right videos or not. That's how you and I would probably, as an average user, that's how we get impacted by AI. But there's so much more that's happening behind the scenes, and it's already making the world a better place.
So before we sum this, podcast, so I would like you to say a few words to the aspiring data scientists that are associated with us, the learners that have taken the courses from us. So would you like to say a few things that will help them?
Sure. Yeah. My advice to all the aspiring data scientists, and this learning of mine has of course also come through taking so many sessions with Intellipaat and having interacted with so many students. My honest advice is the transition into the field of data science is not a flip of a switch. It's not about just doing a course. Of Of course, you need to do the course. Of course, you need to have a structured learning path. But with that also comes the responsibility of spending time and effort in exploring what's out there. This is an ever-evolving field, right? Today, the learnings that I have had in this particular industry, one of the biggest learning that I've had in this industry is to be updated every day, right? Is to stay updated every day, right? Learn the latest happenings in this particular field. There's active research happening in almost every nook and corner of the field of data science. So if you think it's an industry where you could learn once and then reap the rewards for the rest of your life, unfortunately, this is not the field where you need to spend your time on. Then there are other industries where you can definitely do something like that. But with the field of data science, the requirement from a data scientist or requirement from practitioner of the field of artificial intelligence is to stay updated almost on a daily basis, because what I've learned yesterday is not relevant today, and that's at the pace at which this industry is pretty much evolving. So stay updated. That's the only way to stay relevant. Else, I think what will happen is we might have knowledge which is a little obsolete, and that would not stand you in the race, let's say, of building like the most cutting edge solutions. If you really want to get there, then the only way to do that is to be able to stay updated, keep learning, keep trying things, fail fast. That's the only way to operate in the field of AI and data science. That's it.
Alright. So before we go, one last question. If you had to choose between Pytorch and Tensorflow, which one would you?
Yeah, this is like a question that all of the students ask.
Yes.
I'm going to give a little bit of a philosophical answer here. I think as individuals, we need to kind of move away from picking tool A versus tool B. The objective is to solve a problem. It doesn't matter which tool comes to my hand. If you are a newbie, you want to learn one tool, you can probably pick Pytorch over Tensorflow. But as a practitioner in the field, it should not matter to you what tool you need to pick to solve a problem, right? You are expected to solve a problem, which means if it is Tensorflow, it is Tensorflow. If it is Pytorch, it is Pytorch. Just be opportunistic. And that's the only way to solve a problem. So I think it's a tool at the end of the day. This is going to go, something else is going to come, right? Tensorflow might get killed, something else might come. Pytorch might get killed, something else might come. So this, again, as I said, this field is ever evolving. The easiest thing to do in this industry is to learn a tool. So yeah, it shouldn't matter in my opinion. But I would probably pick PyTorch over TensorFlow. That would probably be my preference, so to say.
Alright, sir. So it was very nice having you with us. Thank you so much for joining us today.
No, pleasure is mine. Thank you so much.